Solar eclipses are amazing and awe-inspiring phenomena, and they've also been great for science. Hi, I'm Cameron, and this is Minute Earth. Solar eclipses are intriguing and remarkable, so even ancient civilizations were careful to write them down when they happened. This means we have lots of detailed eclipse records from throughout history. Many years of studying eclipses taught us that they occur in a very predictable pattern, which is so consistent that we can extend it both into the future and into the past to predict and retrodict solar eclipse events. When scientists use computer models to rewind the movements of the Earth and Moon, they predict that an eclipse should have been seen along this path in 136 BCE. But this tablet suggests that an eclipse was seen at the same time, but thousands of miles away in the city of Babylon. From this and other eclipse records, scientists noticed that the farther back in time they went, the further off their predictions were. From that, scientists concluded that the Earth's spin is slowing down over time. Modern astronomers had suspected that the moon's gravitational pull, the same pull that creates the tides, was slowing down our planet's spin, making our days longer. But eclipse data told us precisely how much the Earth is slowing down. The length of a day increases by 1.8 milliseconds per century. And this wasn't the only time eclipses had a hand in a big discovery. Scientists used eclipse observations to confirm Einstein's theory of general relativity, which predicts that massive objects have so much gravity that they noticeably bend beams of light that pass by them. Einstein's theory predicts that an object the size of the sun should produce a considerable bend, causing stars appearing near it to show up in slightly different positions than normal. To test this theory, astronomers took a photo of the sun during the totality of an eclipse, when stars appeared next to it. When they overlaid another photo of the same stars taken at night, they found that some of the stars had indeed shifted their apparent positions. This helped establish general relativity and laid the groundwork for us to have nice things like GPS on our phones. On a lighter note, eclipses also helped us discover helium. In 1868, an astronomer named Jules Janssen was interested in the sun's corona, the super hot layer of plasma surrounding the sun. The corona emits its own light, and Janssen knew that if he could analyze that light, he could figure out the corona's chemical composition. At the time, the corona was impossible to see under normal conditions because the rest of the sun was just so much brighter, and there was no way to block out that light. Again, an eclipse was the answer. In fact, that ring visible during a total eclipse is the sun's corona. By analyzing the wavelengths of light coming from the corona, Janssen and his colleague Norman Lockyer were able to identify the individual elements that make up the corona, including one previously unknown element, helium. Eclipse science goes beyond just those examples. We've used eclipses to study how the sun's corona creates solar winds, and how those solar winds affect the Earth's atmosphere. So eclipses are beautiful and awe-inspiring phenomena, and they've also brought some amazing science to light by darkening the sky. If you live in North America, there are two great chances to actually see an eclipse soon. There's an annular solar eclipse on Saturday, October 14th, 2023, and a total solar eclipse on Monday, April 8th, 2024. Both will take long, sweeping paths across the US, Canada, and Mexico, and we're super excited for both of them. We teamed up with NASA's Heliophysics Education Activation Team to make videos like this to explore the science and wonder of solar eclipses. NASA HEAT's mission is to provide educational guidance for learners of all ages to deepen their understanding of our sun and its effects on Earth and the solar system, in an effort to bring NASA out of the lab and into learning spaces like classrooms and even YouTube to inspire future scientists.